Let me tell you an interesting fact. A fact that may not make much of a difference to you or your daily life, but nonetheless, it is interesting. Do you know about Voyager 1? Yeah, the spacecraft that was sent in space in 1970s that has left the solar system last year in 2023. Actually, 1 year on Voyager 1 will be equals to 0.999997 year on Earth. That means that the time here on Earth is running a little bit faster than the time on Voyager 1. How come? Yes, time dilation. And this is what we are going to see in this video. If you're a science student, chances are more that you have heard about this term, time dilation. But what does this mean? It means that time is not absolute. It means that 1 second for me when I'm stationary, I'm sitting, would be different than 1 second if I was running or in motion. Or the other way is 1 second for me would be different if I was here on Earth versus if I was out in space. All the satellites that are put in the space orbit, clocks running in those satellites run differently than the clocks that are here on Earth. But time dilation was not always a fact. In fact, before Einstein, time dilation was not even conceptualized. Like, people thought that time was an absolute thing, it never changed. What changed was the speed, and that included the speed of light. That means that if a person who is on a train that is moving throws a ball at x kilometers per second, plus the train is y kilometers per second, then the speed of the ball would be x plus y kilometers per second. And same was thought to be true for light. If a person turned on the flashlight in the train that was moving, then the speed of light would be different, would be more if the torch or flashlight had been turned on a stationary object. So as per Newton, time was an absolute thing, means 1 second here on Earth would be 1 second everywhere in the universe. No matter you were in spaceship running at the speed of light, here sitting on Earth, or maybe near a black hole. You know, back in old days, it was thought like much like sound, which requires air molecules or some sort of medium to travel. Light also requires some sort of medium, but there was no medium to be seen. So they created one hypothetical medium and they had to name it. So they named it ether. And they said that, well, ether is omnipresent. It is present across every place in this universe. If ether is present across all the places, so it must be around Earth. And as Earth revolves around the sun, it must also be dragging that ether along itself. And Michelson Morley thought that if the light coming towards Earth was in the direction of ether, then the speed of light must be more. And if it was in opposite direction, then the speed of light must be less. They had their own apparatus and they tried to calculate the speed of light multiple times. And each time they got the same value. Fast forward few years, and 1905 Einstein published his papers. Well, the time is not an absolute thing. It is the speed of light that is constant, that is absolute, but time is rather, flexible thing, time dilation. That means that does not matter if you are sitting or running on a train and then turning the flashlight on, the speed of light will always remain the same. So if the speed is same, then something must change, and that something was time. It was deduced that not only motion, the speed has effect on time, but the gravity also has. So anything that has some mass, anything that is heavy, like Pyramid of Giza, like Earth, Sun, black hole, all these objects have some influence on time. So there were two kinds of time dilation. One that was affected by velocity and the other one that was affected by gravity. Yeah, now back to Voyager 1. You know that Voyager 1 is out of our solar system. So gravity exerted by our solar system on the Voyager 1 will be negligible now. That would mean that the clock running on Voyager 1 would run a little bit faster. And what about the velocity? The speed at which Voyager 1 is running away from us is 17 kilometers per second. That's huge, but not that huge. In fact, it is minuscule in front of speed of light. But even this small speed has some impact in time. It slows down the time. So with gravity, the time speeds up. With velocity or speed, the time slows down. Do they cancel out each other? Not really. That is the reason time running on Voyager 1 runs a little bit slow, like 2 seconds slow. But 2 seconds does not sound too much. Scientists do have to take these minor changes into account when they are communicating with Voyager 1 or navigating it through the space. It's more than 100 years since Einstein proposed his theory of relativity, the general theory and special theory, and still it holds true. Alright guys, hope you liked this video. If you did, please give it a thumbs up, put your valuable comments in comment section, and I'll see you next time around. Bye bye.